Bismillahirrahmanirrahim. Today we are going to learn about the lungs volumetry. Lungs volumetry is the measurement of lungs volume. Simply, this is also called spirometry. And the apparatus which is used for the measurement of lungs volume, that is called spirometer. That is also called plethysmometer. The volume of lung can be divided into four types. Number one, that is tidal volume, inspiratory reserve volume, expiratory reserve volume, and residual volume. First of all, the tidal volume. Tidal volume is the volume of air breathed in and out of the lungs in a single normal quiet respiration. It means that during rest, the volume of air which we inspire and which we expire, the volume of air which is inhaled or exhaled during rest, that is called tidal volume. Tidal is derived from the word tide. Tide means wave. So the wave of air which goes in and comes out of the lungs, that is called tidal volume. That is normally half liter, that is 500 ml, and this tidal volume signifies the normal depth of breathing. This means that it helps in the evaluation of normal breathing. It helps in the measurement of normal breathing, or it helps in the measurement or in figuring out of the depth of the breathing. In this diagram we can see, for example, this is inhalation and this is exhalation. This is inhalation and this is exhalation. The amount of air which is inhaled will be equal to amount of air which will is exhaled up the lungs. The inhaled air and the exhaled air, the inspired air and the expired air will be 500 ml in volume. That is the normal tidal volume. The second one is inspiratory reserve volume or inspiratory reserve volume. That is an additional volume of air that can be inspired forcefully after the end of normal inspiration. It means that when we inhale the air normally, and if we want to inhale further air, we can inhale forcefully. That volume of air which can be inhaled forcefully after the normal inspiration, after the normal inhalation, that is called inspiratory reserve volume. For example, this shows the inspiratory reserve, this shows the tidal volume of inspiration, this shows the tidal volume of expiration, this also shows the tidal volume of inspiration from this point to this point. Now the volume of air which start from this area, and ends on this area, this graph, this shows this wave like structure. This shows the inspiratory reserve volume from this point to this point. This is the volume of air which comes after the tidal volume, which can be inhaled forcefully after the tidal volume, that is called inspiratory reserve volume, and that is round about 3.3 liter in volume, or 3300 milliliter. That is 3.3 liter, that is in normal adult. So this is the volume of air which can be inhaled after after the normal tidal volume, which can be inhaled after the normal inspired tidal volume, which can be inhaled forcefully. This is the forceful inhalation. This is that is what we call the inspiratory reserve volume. Now the expiratory reserve volume. Expiratory reserve volume is the volume that is additional volume of air that can be expired out forcefully after the normal expiration. Now in this graph we can see this is inhalation, this is exhalation, this is inhalation, this is exhalation. Though from this area to this area you can see this is inhalation and this is exhalation. This is exhaled tidal volume, this is exhaled tidal volume. So from this point to this point it shows the inspiratory reserve volume, the expiratory reserve volume. This is the volume of air which can be expired after the tidal volume, after the tidal expired volume, or after the exhaled tidal volume. So this is the volume of air which can be exhaled, which can be which comes out of the lung forcefully after the tidal volume, that is called expiratory reserve volume. That is round about 1 liter or 1000 ml in volume. So this is the expiratory reserve volume. This is the volume of air which can be expired after the tidal volume. This graph, this area shows the normal tidal volume, while from this area to this area, this shows the this shows the expiratory reserve volume. So now the residual volume. The residual volume is the volume of air remaining in the lungs even after the forceful expiration. The volume of air which remains in the lungs after forceful expiration, and the volume, that volume of air, that is called residual volume, which remains in the air in the lung, which you cannot exhale, which one cannot exhale, which any individual cannot exhale out of the lungs, that remain there in the lungs, that is around about 1.2 ml in liter, and volume, that is 1.2 liter in the volume. So this the lung cannot be emptied completely even after forceful expiration. So the volume of air which remains in the lung even after the expiratory reserve volume, even after the forceful expiration, that is the residual volume. There is I can say from my own belief that this residual volume should be exhaled after death. This residual volume can only be exhaled after death. Before death, this residual volume cannot be exhaled out of the lung. So the next one is total lung capacity. In this diagram you can see there are two types of diagram over here. One is this one and the other is this one. Total lung capacity is volume of air present in the lung even after deep inspiration. It includes all the volumes of the lung. It includes all the volumes of the lungs. You can see over here that the total lung capacity TLC is equal to inspiratory reserve volume, tidal volume, expiratory reserve volume, and residual volume. These four volumes combine together to make the total lung capacity. Over here this is mentioned that 3.3 liter, 0.5 liter, 1 liter and 1.2 liter of residual volume combined together to make 600 ml of volume, that is called total lung capacity. In this diagram you can see over here that these waves represent the tidal volume. These waves represent the tidal volume, and from this area to this area, this represent the from this area to this area, this represent the inspiratory reserve volume. This is 3.3 liter. So this is inspiratory reserve volume. This is 3.3 liter. Now from this area to this area, this is tidal volume. This is tidal volume. From this area to this area, this is expiratory reserve volume. So from this point to this point to last point, from this point to this point, this shows the residual volume. This is 1.2 liter. So now starting from this point to this point, this shows the expiratory reserve volume. The inspiratory reserve volume, that is 3.3 liter. 3.3 liter plus 0.5 liter of tidal volume plus 1 liter of expiratory reserve volume, and 1.2 liter of the residual volume combined together to make the total lung capacity. So this layer, this green layer, represent the inspiratory reserve volume. This pink layer represent the tidal volume. This bluish layer represent the expiratory reserve volume, and this yellow layer represent the residual volume. So all of these volume combined together to make the total lung capacity, that is round about 6,000 ml or 6 liter. Now this graph, this slide is very important one. This is the last slide, but this is very important. I have not written the detail of this, but you should be quite attentive to this slide, because this is a very important one. In this you can see this green layer represent the inspiratory reserve volume. This pink layer represent the tidal volume. This bluish layer represent the expiratory reserve volume, and this yellow layer represent the residual volume. So first of all, this one, this is called inspiratory capacity. Inspiratory capacity is the combination of inspiratory reserve volume plus tidal volume. The combination of inspiratory reserve volume plus tidal volume is called inspiratory capacity. You can also say that inspiratory capacity is the capacity of the lung, or the amount of air which can be inhaled after normal expiration. The volume of air which can be inhaled after normal expiration, after normal tidal volume expiration. So this is the combination of tidal volume and inspiratory reserve volume. So the value, these value combined together, 3.3 liter plus 0.5 liter, that is 3.8 liter. This represents the inspiratory capacity. Now the second one is vital capacity. Vital capacity, this is very important. In spirometer, we figure out this vital capacity to sort out some pathology, some diseases inside the lungs. That's why we figure out the vital capacity of the lungs in the spirometer or in the plethysmometer. This is the combination of inspiratory reserve volume, tidal volume, and expiratory reserve volume. You can simply say that the volume of air which can be inhaled after forceful expiration of air, the volume of air which can be inhaled after forceful inspiration, after forceful expiration of air. If we expire that expiratory reserve volume 1 liter, then the volume of air which can be inhaled after forceful expiration, that is called the vital capacity. That is called vital capacity. So the combination of inspiratory reserve volume, tidal volume, 3.3 liter plus 0.5 liter plus 1 liter, that is 4.8 liter. Combined, that is 4.8 liter. That is the vital capacity of the lung. The next one, this is functional residual volume. This is called functional residual volume. The functional residual volume is the combination of expiratory reserve volume as well as the residual volume. Normally, in the normal circumstances, when we are at rest, when an individual is at rest, at that stage or at that very moment, the individual do not expire this volume, do not expire this blue volume. It's a normal condition, we do not expire this volume. Now when we forcefully expire the air, we reach this point, we expire this also. But normally we do not expire these two volume. So the combination of this volume, residual volume, and expiratory reserve volume, these two combine together to make the functional residual volume. This volume of air exists inside the lung after normal expiration. The volume of air which can exist inside the lung after normal expiration, after normal tidal expiration, so that is called functional residual capacity. How will you find out the value of this one? The residual volume is 1.2 liter and this is 1 liter. So 1 liter and 1.2 liter makes 2.2 liter. So the functional residual volume is 2.2 liter. And the next one is total lung capacity. So this is very easy. This is very much easy. The combination of all these values, the combination of residual volume, expiratory reserve volume, tidal volume and inspiratory reserve volume make the total lung capacity, that is round about 6 liter. In this, once again, you can see to this graph, this is tidal inhalation or tidal, uh, you can also see, you can also call it inhalation or inspiration. So this is the tidal inhalation, this is the tidal exhalation, this is the tidal inhalation. From this point to this point, this is the inspiratory reserve volume or inspiratory reserve volume, that is 3.3 liter. Now from this area to this area, this is the tidal expiration or tidal exhalation. From this area to this area, this shows the expiratory reserve volume, the volume of air which is expired after the tidal volume, that is around about 1 liter. And the volume of air which remains inside the lungs even after forceful expiration, that comes below this point, and that is called residual volume. This was all about the total lung capacity, the lungs volumetry. This can be figured out with the help of plethysmometer and the spirometer, and this phenomena is called spirometry.